So welcome to the first Soils Network of Knowledge webinar for 2020, March 2020, Legacy Phosphorus, Are We Falling Asleep at the Wheel? From Simon Clarendon, brought to you by the New South Wales DPI Soils Unit. Now, it's a great pleasure. I'd like to introduce Simon, who's presenting today's webinar. Simon is a researcher with the New South Wales DPI Soils Unit, based in Tamworth. He has a background in nutrient management, in particular the mitigation of phosphorus loss from sandy soils. Simon is currently working on a variety of projects ranging from assisting with developing new modules for soil constraints in APSIM, reviewing the Better Fertilisers Decisions for Cropping database and program, and assisting with crop trials run by the Soil Subunit out of Tamworth. Now I will hand over presenting rights.
Thanks for that, Luke. So obviously today I'm going to talk on legacy phosphorus, and I did have some help with some of the data from Dave Weave and Rob Summers in the West. So you're probably all asking, what is legacy phosphorus? Sorry about that, we're having a bit of an issue with technology. So we have processes of phosphorus movement through the landscape. So that's what we can see on the screen here. We can see it's quite complex. So we have losses, leaching, runoff, desorption, adsorption. In the case of nitrogen, it's volatilisation. So we try to reduce the impact. We implement management practices, which includes different fertilisers types like slow release, spreading of amendments such as amended bauxite. We do soil testing. We spread fertiliser calibration, alternative fertilisers, different types of pasture species to mop up nutrients, bioremediation trenches, effluent management, reusing effluent on farms. We can go beyond the farm fence and we put in riparian buffers. We also do riparian management, which is along more as a catchment scale. We put in biofilters like gravel. We develop wetlands to store phosphorus. We do things such as the Dawesville cut to try and mitigate the nutrients that we're settling in the estuary in the west. And we also do things like dredging. However, the phosphorus measured at the catchment level, for example, the water quality in streams and estuaries does not match what is being lost at the edge of paddocks. Thus, it is being held somewhere. This is what we call legacy phosphorus. So what is legacy phosphorus? I like to split it up into two things. The general description in the literature of legacy phosphorus is soil legacy phosphorus. That is the elevated levels of phosphorus in soils due to historical and continual applications of phosphorus above the needs of the crop and the plants. However, we can further break it down to differentiate between soil legacy phosphorus and phosphorus retained in the greater landscape, which I call catchment legacy phosphorus. Soil legacy phosphorus is inherently linked to catchment legacy phosphorus. So the reason I differentiated between soil legacy phosphorus and catchment legacy phosphorus is that the soil legacy phosphorus can be an opportunity or a risk. So let's talk about the opportunity first. We have on this screen, we've got the chart. We have on the left is the cumulative proportion of samples that have a phosphorus fertility index of 1 or greater. It's the cumulative proportion of samples. On the x-axis, we have the phosphorus fertility index. So a phosphorus fertility index value of 1 is to achieve a 95% relative yield, assuming nothing else is limiting production. Is it effectively the amount of phosphorus required to sustain production without a yield deficit? So if we go up the line and we look at the green and the blue line for Western Australia and New South Wales, we can see that 40% of the samples analysed were below 1, so that means they'd have a yield deficit. But that says there's 60% above the line that analysed above the line of value of 1, that's the opportunity. So we utilise the portion of phosphorus available in the soil to reduce inputs, save money while maintaining productivity. The risk is a continual application of phosphorus where it is above agronomic optimum, that is a greater phosphorus fertility index value of 1, allowing a high potential of phosphorus to be lost to the wider catchment. The outcome that greater than 60% of the soil samples were above a phosphorus fertility index of 1 highlights the importance of soil testing as well as tools such as BFDC, which is Better Fertiliser Decisions for Cropping database, which is nutrient response curves for cropping, as well as Better Fertiliser Decisions for pastures, which provide a range for which soil test phosphorus should sit to get the desired yield response. And programs such as whole farm nutrient mapping, which is in the west, which provides visual information on which paddocks need or do not need phosphorus. So I want to present or explain what equilibrium phosphorus concentration is. I've kind of got the slides in the wrong way, but we'll go with what we've got. Equilibrium phosphorus concentration in the sediment, so we're looking at the catchment legacy phosphorus now, is the concentration where no phosphorus is retained or released by the sediment. So to put it explained in terms, if we have a concentration of phosphorus in the sediment at 0.02 milligrams per litre, and we have a phosphorus concentration in the water of 0.03 milligrams per litre, then the phosphorus will absorb to the sediment. If we change that and we have a concentration of phosphorus in the water at 0.01 milligrams, but the EPC of the sediment stays the same, then the phosphorus will desorb from the sediment. So if we have the same concentration in the water in the sediment, then there's no absorption or desorption of phosphorus. So catchment legacy phosphorus only presents itself as a risk. So the stream sediments have the capacity to retain or release phosphorus, a measure of the point which I've explained before where no phosphorus is retained or released. So using the EPC of the sediments and historical water quality of 8 sites located in Oyster Harbour catchment and Wilson Inlet, where the work was done in southern Western Australia, we identified that the sediments are net retainers of phosphorus. So you can see here that on the x-axis is the EPC of the sediment, which is a measured value, and then we've used some values on the y-axis from water quality, historic water quality data. And the 1-to-1 line, you have release if the concentration is greater than the sediment EPC is greater than concentration of the water. We can see that all the data points sit to the left of that line, so therefore they are net retainers of phosphorus and therefore they contribute to legacy phosphorus stocks. So to further illustrate legacy phosphorus and its dynamic and that the equilibrium will change, this is a bit of a scary graph, but bear with me. We have time on the x-axis in days, so that's time over a period which samples were taken, and we have the amount of phosphorus absorbed on the y-axis. The closed symbols are iron-rich gravels that have not been exposed to phosphorus before. The open symbols are iron-rich gravels or lateritic gravels taken from an environment exposed to phosphorus previously. So the fresh gravel at a solution concentration of 0.7 milligrams per litre will absorb phosphorus, and it will most likely have an EPC lower than the concentration of the solution, thus enabling it to absorb a considerable amount of phosphorus. However, if we look at the previously exposed phosphorus, we can see that no sorption or very little sorption occurs, and that's the lower arrow. However, the open exposed fresh gravel solution concentration of 0 milligrams per litre, it will not desorb, so there'll be no real desorption. But the gravel previously exposed to the phosphorus desorbs a larger amount as the EPC of the sediment is greater than the concentration of water, thus allowing desorption until a new equilibrium is met, which is these two here. So we can see in the stream that's got phosphorus, gravel's already been exposed to phosphorus, and the concentration of water is lower, we can see that it's going to desorb nutrients. So let's have a look at a larger scale. A good example of legacy phosphorus is the use of amended bauxite residue, which was alkaline, which in the 30-hectare catchment was applied to the soil surface as well as all the drainage lines. So that includes drain beds, stream beds within that 30-hectare catchment. So the open values here, the open symbols here, that is untreated. The closed symbols are the treated symbols. So the phosphorus applied post-application of the alkaline would be retained and not leached out, and the phosphorus already below the alkaline in the paddocks applied, so that's under the ground level, so that's like below surface, would be exposed to more, would move across the drainage lines. So in WA, in these areas, it's subsurface flow dominant. So what happens is the water will flow under the ground and then out into the streams or into the drainage lines. And so it exposes it to more alkaline in the drainage line, and there we reduce the phosphorus export, which is these black dots here. So in the end, even though we might have missed the phosphorus that's already in the soil, when the movement of water through the landscape, it's moved out into the drains, and the alkaline in the drains have absorbed that phosphorus. However, if we look at the 4,000 hectare catchment in the same area, the alkaline was applied to the paddocks surface, but not applied to the main larger drainage systems. Thus, we do not get an immediate reduction, but rather a gradual reduction in the phosphorus is noted, which is the grey area is the same area as January 91 to October 94. This indicates to us the stream will be releasing phosphorus from the sediment due to the incoming water concentration being lower, as the alkaline has reduced the phosphorus concentration moving into the stream's drains than the EPC of the sediment, thus masking the effect of the broad application of phosphorus loss mitigation management. And that gives a good understanding that phosphorus, unless you can cover it all, you're going to have issues with legacy phosphorus. So what does this mean? In summary, we implement a management practice known at the edge of the paddock to reduce phosphorus loss, but it may not be reflected at the catchment scale. So to that whole square there is the landscape loss, and we've reduced it by, say, a third, for example. However, the stream's got a legacy phosphorus in it, and what happens is it then releases because we've reduced the concentration coming in, and the output is that we don't see the full effect of that management practice implemented. So what potentially we see is where there's no management implemented for reducing phosphorus loss, we can see that the landscape, it's the whole box. The stream will retain some, so it's actually the stream that makes it look like it's done. It's the stream has retained some phosphorus, so it's reduced the actual catchment P loss, and then so you can potentially not see a difference. So, have we been asleep at the wheel? At a catchment scale, water quality is measured and used as an identifier to determine effectiveness of best management practices implemented at both a paddock and a catchment scales. So in some countries, and dependent on the soil type, the depletion of this legacy phosphorus stocks in soils and sediments estimated in 100 years, and it comes in part down to soil type. So it might be decadal in the Swan Coastal Plains in the west, could be longer elsewhere. And there is, I was reading an article this morning that indicates it ranges from from less than a year on some soils to greater than 80 years. So have we been asleep at the wheel? Yes. So the take-home message is we need to effectively communicate the notion of legacy phosphorus to the broader stakeholders and its implications in the best management practice effectiveness and the water quality improvement and the realistic timeframes for these changes given the influence of legacy phosphorus. And that's it, Luke. Thank you.
Thanks, Simon. Very succinct. So now's the chance to ask you questions. I've got one for you, Simon, and it's around, I noticed that a lot of your data was from Western Australia. So I'm just interested in how relevant what you're talking about is to other parts of Australia or even the world.
Thanks, Luke. In America, it's a very large issue, and it's only probably in the last five or so years that legacy phosphorus has been talked about. It's probably not so much about how it gets there, but the fact that it is there and that there will be the effect of, if we implement practices, that we're not going to see it straight away, the benefit of those management practices. So yeah, it's worldwide, it's an issue.
Michael McDonald has typed in a question. So Michael's asked, can you fill out, in other words, give us more information on the environmental problem caused by the legacy phosphorus, so the problems that it causes for the environment?
Yep. So the broader issue is in catchments is obviously, generally it comes down to algal blooms is the big one that's obviously discussed a lot when it comes to too much phosphorus, and phosphorus can be the limiting factor in a lot of those algal blooms. So the case is to reduce that nutrient input and then reduce the opportunity for algal blooms.
Cameron Gouldy's got his hand. Oh,
hi Simon. Cameron Gouldy here. How are you?
Good, thanks.
PERI, P-E-R-I, the PERI index is Colwell P divided by PBI, and there's some discussion at the minute about its broad scale use as a P loss risk index at the paddock scale. Have you got any thoughts on the application of PERI in the context of P loss?
I haven't, to be honest, Cameron, I haven't really delved into that. Haven't looked at PERI close enough to comment on it. Happy to talk to you about it afterwards. One thing that I do notice is there worldwide there, or in the US at least, there are some indexes that I seem, when I'm doing the reading, there seems to be quite a few indexes that are based around that environmental risk rather than just agronomic risk. So
we've got a question statement from Nathan Robinson.
A good presentation. Just a query about what are the opportunities for legacy P in current farming systems, especially when there's a lot of discussion about nitrogen management and legumes and other things. So that's one. And the other question was around P banding at depth. Is it an opportunity or is it potentially going to raise other issues?
Yep. I'll do the P banding one. A lot of it comes down to the movement of the nutrient through the landscape. So effectively for phosphorus, if you've got fresh binding sites, the deep banding is generally in soils that are obviously high binding nutrients, and we've depleted the stock. So I would say if you kept doing it and it got to the point where it's saturation and started moving out of the landscape, then it'd probably be a problem. But in saying that, it could be a problem, but if we're depleted the stocks, we're only topping them up or trying to get them back to where they're agronomic optimums. And at subsurface too, depending on the flow pathway, it comes down to flow pathway really. If it's like a sand and it's subsurface flow dominant, then yeah, it'd be a problem, but they generally don't do that deep application. So whereas on a verticile, it'd probably just stay in its area pretty much. And can you clarify the nitrogen question?
Oh no, it was just more about, are there agronomic opportunities with legacy P?
Yeah, it's if it's above the agronomic max, like if it's above the agronomic maximum and you're trying to put more on, and you're not going to have a yield deficit because you don't add it, then I just see it as a saving in dollar value that you can put towards either another nutrient that's in deficit or something else on your property.
Now we'll go to Sarah Dad, and so Sarah asks, what has been done to address these issues with stakeholders, and how well are the BMPs, the best management practices, implemented, please?
Good question. I'm not sure I would be able to ask those questions, but in the case of, soil testing and nutrient management, it's a lot of comes down to behavioural change and seeing the benefit. It's a long process. Yeah, I wouldn't say a lot of it comes. Yeah, I'd say a lot of it comes down to behavioural change and getting that across and outlining the benefits, and whether that social license is going to become more into play in the future is another thing to be looking at.
Fair enough. So Cameron's added, hi again, is not the challenge that the agronomic targets are a magnitude above the environmental water phosphorus concentration targets? You want to clarify?
No, g'day again.
Hey,
well,
Cameron.
I'll be interested in the general discussion around this. There was a good paper just recently by McDowell in New Zealand, and he clearly showed, and it was very relevant to the discussion that you've stimulated here, where he showed on specific soil types that the build-up of existing soil P would take decades to reduce to meet the water quality targets, but that it would only take a year or so to bring it back to the agronomic targets. And therefore there's a disparity between meeting agronomic targets, which you highlighted in one of your slides, showing the proportion of soil tests that are well above those agronomic targets. But even addressing those that agronomic challenge of too much phosphorus in many of our agricultural soils does not address the fact that that is going to be a long-term source of P supply to water, be it either leaching, but probably more importantly, surface flow for many decades.
Yep. No, I totally agree. And then I suppose that question that stimulates the question is it a trade-off? Is it a consequence? So that's...
Well, I mean, there's no, the issue at the minute is that there's no penalty for diffuse flow of phosphorus. The best we can do, I think you've answered your question, the best we can do is try to convince people to not oversupply from an economic perspective and meet those agreed to phosphorus agronomic targets, be it for crops or for pastures. And then there's mitigation strategies that are going to have to be put in place to protect waterways, which is a somewhat separate activity.
Correct, yep.
Thanks, Cameron. So we've got a few more. Andrew McKay.
Just a query about other than bauxite, are there other amendments that are effective, and what sort of rates could they be used at?
Good question. I presented this in December, and people were putting cracked pea gravel in drains, or they wanted to put cracked pea gravel. But the consequence is that you're going to have to, if you had even something like that, you're going to have to it's going to absorb to a point, and then you're going to have to pull it out anyway and then refresh it. So besides that, I don't know of any products in particular that are a long-term fix for it, I suppose.
Okay, thank you.
Thanks, Andrew. We've got two more. We've got Chris Dowling has made a quick comment here, but it's a pretty important one.
The observation that this source mobilisation, delivery and sensitive site process is covered to a degree in the FertCare-C training from Fertiliser Australia. That program is about to be, I suppose, reviewed, or I'm doing a review of the content to make it more focused on loss process, on agronomists understanding loss processes that relate to either the source, whether the mobilisation characteristics, the delivery, and certainly the delivery post farm gate to a sensitive site, rather than just focusing on the reef and the swan catchment as the outcomes of all of this. So I think a better training of the people that are recommending the fertiliser on what the process is. Is there a sensitive site? What's the delivery mechanism? What's the mobilisation into delivery? And what's the source and the source characteristics that increase the risk? Will go a long way to giving people the tools to address this.
Yep, it's a very good point.
Thanks very much, Chris. Great words of wisdom. A good lead. And Graham Schwanke gets the last word at this point.
Oh, hello. I just have a question really about the alkalome that you mentioned in the talk, whether that's being in common use now, or was it just a bit of a research topic at the time?
It was a research topic at the time that if you Googled it, you'd probably find some newspaper articles about it. So yeah, it's not in use.
So there's no other product doing that sort of function that's being used in the area?
No, not from what I know, and I've been out of that work for probably 10 years, that stuff. So yeah.
Excellent. Thanks, Graham. Thank you very much again, Simon, for your efforts there. Terrific discussion that's come about as a result of it. So that looks like about it. Thanks again, Simon, and we'll look forward to catching up with you all next time. So bye for now.